Hello, welcome to equations with many solutions or no solution. Up to this point, we have learned about equations where you had a solution. X equals 5. That's definitive. We know that X is 5 in this case. And that is a one solution problem. There are more than these types of equations out there. I'm sure you've run across where you've tried to make an equation and it just didn't work. So we're going to learn about those today. So our first example is use the properties of equality to simplify each equation and tell whether the final equation is a true statement. Our first equation is 4x minus 3 equals 2x plus 13. And the first thing that they want us to do is to get rid of the whole numbers. So instead of moving the x term first, they want us to move the 3. So we're going to do the opposite of subtract, which is to add 3 to both sides. 13 plus 3 is 16, bring down to 2x. This is gone. 4x is all that's left on the left. Now we're going to move this x term. We're going to move it to the left by subtracting each side by 2x. 4x minus 2x is 2x. These two are gone. All I have left is 16. Now to solve for x, I need to move the 2. Since it's multiplication, I'm going to divide each side by 2. And x is going to equal 8. It is a definitive answer. X is 8. This is a true statement, and it's showing that I have only one solution for this equation. On example B, I have 4x minus 5 equals 2 times the difference of 2x and 1 minus 3. And the first thing I see is these parentheses, so I know that I need to distribute before I go any further. So 2 times 2x is 4x, and 2 times 1 is 2. I can combine my terms over here on the right. So I can take negative 2 plus negative 3, and that's going to give me a negative 5. I have everything else brought down. I have 4x minus 5 equals 4x minus 5. Now, if I want to, I can move the x term. So I'm going to subtract 4x from both sides. And when I do that, that leaves me with negative 5 and negative 5. Negative 5 equals negative 5. Now, this is true. Negative 5 is negative 5. There's no confusion about that. But it's a little odd because we don't have our variable. We lost our variable when we subtracted 4x on both sides. Because it's exactly the same on the left and the right, the statement is true. And there are many solutions. And sometimes they call that infinite many. If you take and look back here at this step here, if you notice we had 4x minus 5 equals 4x minus 5. This is a true statement. They're exactly the same on both sides. And so you can catch that early and know that that's many solutions. Example C, it has 4x plus 2 equals 4x minus 5. I could subtract 2 from both sides. 2 minus 2 is 0. 4x is by itself. Negative 5 minus 2, well, that's subtraction with a negative. So I'm going to change to add its opposite. Negative 5 plus negative 2 is negative 7. Now I can move this x term over to the left by subtracting both sides by 4x. And so 4x is gone. I have nothing here, so that's 0. 4x minus 4x is 0. Negative 7 is by itself. Is 0 equal to negative 7? No, it is not. This is a false statement. It is not equal to negative 7. Because the statement is false, there is no solution. Okay? They want us to work these through and use the properties of equality to simplify each equation. Once we've done that, they want to know, is it a true statement? So if I take 2x plus 1 equals 5x minus 8, the first thing I want to do is to move my x term. So I'm going to subtract 2x from each side. And I get 1 equals 3x minus 8. Now I'm going to move this 8. Since it's subtracted, I'm going to add 8 to both sides. I get 9 equals 3x. And now I'm going to divide both sides by 3. X is equal to 3. Is this true? Is this a definitive? If I put 3 back in here, will it work? Yes, it does. So this is a true statement. The next one is 3 times the sum of 4x and 3 minus 2 equals 12x plus 7. I see the parentheses, so the first thing I want to do is to distribute the 3. So 3 times 4x is 12x. 3 times 3 is 9. Bring down my minus 2 and bring down my 12x plus 7. I can combine these two. 9 minus 2 is 7. So I have 12x plus 7 equals 12x plus 7. And I notice that this and this are exactly the same. Because they are the same, this is true. My fourth one, I have 3x minus 9 equals 5 plus 3x. I want to move my x terms over, so I'm going to subtract 3x from both sides. 3x minus 3x is 0, bring down my 5. 3x minus 3x is 0, bring down my negative 9. Now, is this true? No. Negative 9 does not equal 5. So that means this is a false statement. When you're writing equations with a given number of solutions, you can use the property of equality. You'll have, one of the 3 results. So if we know we have a definitive, if x equals a number, we know that it's a true statement, and we know that it is one solution. If a equals a, where it's the same on the left and the right side of the equal sign, that's infinitely many, and a lot of times we just call that many. If we have a equals b, but b does not equal a, or a does not equal b, that means that this is a false statement. There's no way to make this where they're equal or not equal at the same time. And so that makes it either a 0 or no solution. Okay? Sometimes they ask us to write a linear equation in one variable that has no solution. And the only information they give you is a false statement where it says 3 equals 5. Now, we could add the same variable to each side. So say we add x. So we have 3 plus x equals 5 plus x. Then we can add the same constant to both sides and combine like terms. So let's say we add 7. So we're going to take 3 plus 7 and 5 plus 7. And that's going to give us 10 plus x equals 12 plus x. And obviously that's not going to work. So no matter what, no matter what we do to the equation, it's just not going to work. It has no solution. Here we have some your turn practice questions. On number 6, they want to know if it has an equation that has 1, 0, or infinitely many solutions. So you're going to work out each equation and determine, is it 1, is it 0, or is it many solutions? On 8 and 9, it says complete each equation so that it has the indicated number of solutions. So you want to make this true. So if it says no solution, to make that true, what would I have to put in this place right here to make it where it doesn't work? We want to make no solution to be true. Infinitely many, what would we put right here that would make this infinitely many solutions? Okay. Then you have some practice questions to do at the bottom of the page. If you have any questions, please make sure that you come and ask for help. Thank you.